So the first term of an infinite geometric series exceeds the second term by 2 and the sum to infinity is 50. What will be the common ratio and sum to n term? So let's begin. So here we are going to specify the first term and the common ratio. So let A be the first term of the infinite geometric series and R represent the common ratio. Now we are given that the first term exceeds the second term. So our second term will be A times R by 2. So that means A equals to AR plus 2 and the sum to infinity that's given by 50. So we need to find out the value of common ratio R and the sum to n terms. We know that the sum to infinity of a geometric series or an infinite geometric series, that's A divided by 1 minus R. So that means A divided by 1 minus R. So this value is equals to 50. So cross multiplying we get A equals to 50 minus 50R. Fine. Or solving for R, we will get 50R will be equals to 50 minus A, or R value will be 1 minus A over 50. So we'll substitute this value. So let this be number 2 and let this be equation number 1. So we are using, or we can be substituting the value of 2, value of R obtained in equation number 2 and equation number 1 to get A equals to A times we have R, so R will be replaced by 1 minus A over 50 plus 2. So that gives us A equals to A minus A squared over 50 plus 2. So A and A gets cancelled and we can rewrite this equation as A squared equals to 100. So taking the square root gives us A equals to plus or minus 10. Now that we have the value of our first term A, we can find out the common ratio. So when our first term is positive 10, then R will be equals to 1 minus positive 10 over 50, which is 1 over 5. So this is going to give us a value 4 over 5. And then the other case, when A is negative 10 and R is, then R will be equals to 1. So we have positive 10 over 50. In this case, this will be 6 over 5. Now, our task is to obtain the common ratio and the sum to n terms. So we obtain the common ratio. In one case it's 4 over 5 and the other case it's 6 over 5. Now we want to find out the sum to n terms. We know that the sum to n terms of a geometric progression is given by A times R raised to the power of n minus 1 divided by R minus 1 whenever the value of R is greater than 1. And if R is less than 1, then we have A times 1 minus R raised to the power of n divided by 1 minus R. So this is true whenever R value is less than 1. So these are the two formulas that we will use. Now in the case when R is 4 over 5, so this is less than 1. And whenever it's 6 over 5, it's greater than 1. So that means the sum to n terms that will be equals to the first term, which is positive 10 multiplied to, we'll use this particular formula, 1 minus 4 over 5 whole raised to the power of n divided by, so we have 1 minus 4 over 5. So that's going to give us 1 over 5. So with this will be simply 50. You can check out the calculation. And whenever the common ratio is 6 over 5 and A is negative 10, then sum to n terms will be negative 10 multiplied to, we'll be using this formula. So we have 6 over 5 whole raised to the power of n minus 1 divided by the 6 over 5 minus 1, so that's 1 over 5. So this is also going to become negative 50 in the numerator. So we have two cases here. So in one case, the sum to n terms is 50 times 1 minus 4 over 5 raised to the power of n, and the other case we have negative 50 times 6 over 5 raised to the power of n minus 1. So, and we have the corresponding R value as well.